In my previous video, I demonstrated a new 8-bit processor that I made using the wire wrap prototyping method. They show the wires on the bottom of it. I've removed the chips, and I'll show you why in a minute. So I went ahead and used the same schematics and made some printed circuit boards for the 8-bit processor. This is the circuit board for the ALU. This is the control logic board, and that's the printed circuit board for the main board. So these three boards have the same circuit as the wire wrap prototype, but this allows you to solder it together and to print up as many as you want if your budget holds up. So here are the three boards that make up the processor with the integrated circuits plugged into sockets. This is the arithmetic logic unit board. This is the main board that has the multiplexers and registers on it. And this is the control logic board that has the logic circuits that interpret the instructions. So when I made these, I lined up the connectors. So the main board has a connector for the control board and for the arithmetic logic unit, and the connectors for the arithmetic logic unit and for the control board line up with those, so they can be stacked if you have the right connectors. So here's the assembled processor. The three boards. The top board is the control board, and there are some extras on it. The control board has a 2 megahertz crystal clock. It also has a RC slow clock, and these switches here are a single step clock, and you can choose the clock by the switches here, and it has a reset switch on it as well. So you can see the connector here where the control board plugs into the main board. On the back is the ribbon cable that connects the main board to the ALU board, which is on the bottom in this case. Now, this is just a processor. It doesn't have any memory or input-output ports, so we need to connect it to some kind of system board, and this is where you have some options. In my previous videos about my wire wrap processor prototype, I used a very, what I call, clumsy adapter to connect it to a small 8-bit computer kit that I sell. This is a nicer adapter that I made, and it connects the system connector on the 8-bit processor with a cable that has a 40-pin plug on here that can plug directly into the Z80 socket on the small computer. Now, to make things more interesting, I made this single board Z80 computer that has 64K memory. This computer is capable of running the CPM operating system, and it has a disk drive interface, a 2 megahertz clock, and a serial interface. This one has a connector that I can use with a ribbon cable to connect directly to the 8-bit processor. Of course, you can also remove the Z80 and put in a ROM chip that has the appropriate programs, and you can use this adapter to plug in there also. And I'll assemble this with the processor to make a stack of 4 boards that really represents what I think is the ultimate 8-bit processor, 64K memory computer that I'm going to use. I've brought the 8-bit processor system up to my desktop computer so we can run some programs on it and demonstrate it. So we can plug it into the serial port of the desktop computer to get a display and use the keyboard and display to communicate with the computer. So to operate the computer using the serial interface, we'll start a terminal program. I'm using Minicom in my Linux computer here. And then we can plug the processor in to the 5-volt power input on the main board. And you can see the greeting message come up. Now I'll switch to the computer window view. So here you see the greeting message and the commands that are available in the monitor program. The restart command just restarts the monitor just so you know that it's alive. The dump program will show you the contents of an area of memory. So if we look at 0900 in hex, that's the beginning of user memory. It's full of garbage right now, but it displays a block of memory. The load program will put byte values into memory, so we can put bytes into that same area of memory. We can just put some zeros, and then if we dump that same memory area, you can see the zeros at the top of the block that we just put in there. To demonstrate the bload and run commands, I'm going to load a program into the computer that calculates the value of pi. The window over here shows the program. The binary code is pi8.obj, and I can load this into the computer over the serial port by using the Linux cat command. This is a command that just dumps file contents somewhere, usually used to read text files on the screen, but it will also dump binary data, and I've redirected it to dump it to the serial port that the computer is connected to. So it's ready to go, so I'm going to use the bload command, which is 5. I'm going to put the program at 0900, the beginning of the user memory area. The number of bytes to load is the length of the program, 7734. And now it's ready to transfer, so I will execute the cat command. Takes a little bit of time, and once the cursor goes back to the menu display, we know it's in. Now I'll run it using the run command, which is 3, and the address is beginning of user memory. So this program does a numeric integration of a multi-sided polygon that's drawn inside the unit circle. It doubles the size each iteration, calculates the perimeter of the polygon, and then calculates a value of pi from that. It uses medium precision floating point arithmetic, and takes a while. This processor is not particularly speedy, and it's very simple, but it does work. You can see the values of pi converging on the true value as the number of sides of the polygon increase. So it's just about finished. It takes about 2 minutes to do the whole calculation. I thought this would be a real good test of the processor's capabilities, since it involves a lot of math, and the processor seems to do pretty well with this. So that's about as far as it can get with the floating point routines that it has. Any more precision, the floating point routines start to break down. So that's a demonstration of a simple 8-bit processor. If you are interested in building one, getting the circuit boards or parts, let me know, and I can help you out on that. Thanks. Bye-bye.